So here I'm going to go over a little bit of how we learn and think to give you some insight into this. Well, first off, we may recognize patterns or think a pattern exists is kind of one way we think. We can recognize patterns, can be very beneficial. When we start a car, for example, a certain pattern or sequence we want to become familiar with so we know when something goes wrong. Patterns can also be essential for survival. Knowing that goes from green to yellow to red lights can be very important for safety of us and others. However, sometimes we run into issues where we may try to find a pattern in one that does not exist. Or we could run into a problem where we may fail to see a pattern that does exist. So these are important considerations when we're looking at patterns and trouble we can get into. In addition, storytelling can help fill in gaps for individuals, but often stories can go unchecked. So we want to make sure we're fact-checking and be able to back some information up. The scientific method is a kind of ongoing process that requires observations, hypotheses, and theory testing to develop conclusions. Now, how do you relate this? Well, studying 3 hours once is not as effective as studying 20 minutes 3 times a day for long-term memory retention, which is very important. When you're taking notes during your studying, you should rephrase and rework the material. This will help you be able to remember it for a longer term and also develop connections with that material. You want to review your notes and write questions when and where that you have them. Now, yes, there can be moments of frustration, and this is just part of the learning process. Keep at it. Trust me, it'll work out in the long run. Now, there's null and alternate hypothesis. So in scientists, I mentioned the scientific method. What about these null and alternative hypotheses? How do we test these? Well, the null hypothesis is a statement of the hypothesis simply not being true, and the alternative is the opposite of that. The example here, fertilizer will not make the plants grow better, or fertilizer will make the plants grow better. And we see that listed out here. We see the grass being fed fertilizer. Will that help it grow or will it not? When we're looking at running a trial, we also want to observe the results and document those results. But when we're documenting and making observations for results, it's very important that those results are only valid if there's a comparator, what we call a control group, to make sure the same results would not occur without the test intervention. For example, if we had the fertilizer and the plants grow well anyway, well, it wasn't the fertilizer that made the difference. To look here at how scientists think, they have 2 main forms of reasoning. The first form of reasoning is looking at what we call deductive reasoning. This accepts a general principle based on observations. So if all humans are mortal and Albert Einstein is a human, therefore he is mortal. Inductive reasoning is looking at an observation and going to a broader generalization. If a poll shows 75% of students at school X take the bus to school, Aaron goes to school X, therefore Aaron probably takes the bus to school. So deductive reasoning, the premise is true, the conclusion must be true. Inductive, the premise is true, the conclusion is probably true. Keep in mind these distinctions.